Okay, right. Now, if you can see the learning outcomes of this subject, identify data sources, types, formats, and structures. We have covered this part, and prepare data for analytics and apply data integration techniques. We have covered this one using different techniques and different exercises. Now, today's exercise also will cover LO2, and the LO3 is assessing the data quality measures. This is actually part of the whole process, whether this particular data is applicable or can be used for analysis. Now, that part comes with some knowledge of statistics as well. I believe that you remember things you did about these outliers. If you remember your 5-number summary, you have outliers 1.5 times the interquartile range can be considered as outliers, and then you have 3 times the interquartile range, which is the extreme outliers. So you have some testing to prove whether that particular data belongs to the distribution itself, or whether that's an anomaly. And I guess by the time you might have learned about the class imbalance as well. So all these things is a part of this assessing the data quality measures, etc., and also preparing data for the analytics. Right. Now, from the outline itself, it's very simple, threefold outline. So we done something related to data cleaning. Most of it is about pre-processing and standardization. Then we talked about data integration, how to include data in different processes, and data generalization and summarization. We talked about this, and today's exercise will have this third outline part, which is covering LO2 and LO3 both. Right now, when we go to the Moodle, you can find this text mining and data wrangling in our submission link. So I told you this is an educational experiment related to quality. So you got 2 links. For those who are following this with me in the class itself, you have the chance to upload it within like within the next 1.5 hours by 3 p.m. So once a 10 minutes exercise. So once you do that, you can actually upload it. It's a very simple thing, nothing to nothing sort of to follow with the computer or anything. You just need to draw something or write something and upload. I'll give you the exact instructions, so you have to just follow that. For those who may be looking at this recording or watching this recording after the lecture, you can follow this link and then upload it. So that's part of the process where we talked about the online education versus the recorded lectures and etc. There is no much of a difference, but it's about something about educational psychology. So there are 2 links. So those who are interested, you can go and do this one, and those who are actually following the lecture recording, they need to upload it using the second link for absent students, right? But both of them will be considered as equal submissions, so no issues there. But when we do that analytics part for the education work, that will be taken separately, so that's not part of marking or anything, right? So when you go into the data set, you have these 3 files, 28520txt. It's Sherlock Holmes. Anybody who has read Sherlock Holmes, can you thumbs up? Say thumbs up. Have you read Sherlock Holmes? Sherlock Holmes series? Okay, so I got a 1 thumbs up. I guess others have read it also. Yeah, 3. Right. So the 2852 is Hound of the Baskervilles, Sherlock Holmes story. And this SL Day 2 cricket for CSV is about the recent cricket match, the second day of the Sri Lanka versus Bangladesh cricket match. That's it's a test match where Angelo Matthews scored 199 runs, as I remember. So this is from the Cricinfo second day commentary. And this Titanic.txt is about the Titanic screenplay. So all these 3 data files are available. You can download them from the Moodle and keep it in your computers. So if you are following this with me, you can download it and follow the instructions. Now I'm going back to R. I have set this working everything here, and I've done the coding part as well to save time. So I'm going to start this one. Now let me give you this motivational portion here. So it's actually, this is about the educational thing that I'm talking about. So this is the exact instructional code that I'm going to recite here. So it goes like this. Today, our focus will be on learning the logic behind text mining. Particularly, we start by learning how to extract strings or text from a text file. I'm sure by now you know the importance of word frequencies. We use those to understand the meaning of a text without reading lengthy paragraphs. I'm sure those who are lazy to read will enjoy this. For those who love to read, this will be a great way to get the big picture of a large text while without wasting time. If we have an idea of what we are about to read, we can get better digest the idea. But for both groups, learning how to arrange the set of codes in R will be essential to complete this task. At the end of the day, you will be able to describe the logic behind the coding process using your own words or drawings. I have noticed that while you are able to replicate the codes that I provide, some of you have found issues in applying the logic of programming to new problems. Our task today will help you to better internalize the logical sequence of a programming task. This will also help you to identify which parts of the process you have trouble in understanding the codes, right? So the instruction of this process is, first, pay close attention to the demonstration I am going to do. While doing so, I want you to take a piece of paper and write or draw what you understand about the set of codes I type sequentially. I will explain the nature of the code and what each line in the code means. Your job is to take note of them. In the end, I want you to write down the set of instructions or draw the sequential process so that anybody who reads can easily understand the coding process. You have 10 minutes to complete this task. We caution that the reader should be able to replicate the logic of the code using any coding language. Do not overthink about the special functions available in other languages. Only focus on the steps and write the instructions in simple terms. After completing this task, take a photo of what you have written or drawn and upload that to the Moodle, right? So that is the instruction. So what you need to do is you follow this one and you take a piece of paper while you do this with me, and then maybe you can either write using words or you can draw the way that you like. Drawing things also helps. So either way, you just take a piece of paper and mark how it is done and take a photo of it. Or you can, I would prefer if it is a scan copy, because PDF files are better. So scan it and upload it to the Moodle, where you have this link. The people who are doing it in the class, you can upload it here. For those who are watching it after, you can upload it here. Okay, so right now, as I told you, the task is actually taking the text files and then organizing that text file so that we can get an idea about what is inside. So we don't need to read the entire thing or go one by one about all these things. We can take a macro picture of what is happening. Right now, before going into that, let me sort of going to where we do this. Let me open that up. I think it's somewhere here. Is it? Should be here, right? Now let's look at the first code is about CSV, I guess. First code is about yeah, quick info, right? Let me open this up. So here you have quick info SL2. Yeah, this is the data file that I have with me. If you look at it closely, this is actually Sri Lanka Bangladesh second day. So all these things have been copied or scraped out of the quick info web page. So everything is here. So what happened and the commentary about what has happened is here. So it's a very long CSV file. It contains the way that people scored and what happened during the match. Everything is here. So you can actually take that from the Moodle. So this is the file that we are going to use, right? So it's actually a very long list of strings with what has happened and what went in the match. Oh, everything is there. Now, when you go to the R Studio, I'll explain one by one. When you start R, first of all, check whether you are in the correct working directory. So check what is your working directory first. That's very important because people tend to forget where they are working. So get WD will give you the working directory. So I am here. It's in my working, installed directory. So I need to set my file path to the place that I have my data file. So you saw where it was. So I'm going to run this one to include that in the file path. Right. So remember what I did. I initially checked for my working directory and I took a string mentioning my file path and I'm going to set my working directory to that file path. So I'm going to run this and set WD will set my working directory to that particular file path. So if now I do the get WD and check where I am, it will show me where my current location is. So I'm going to remove if there is any what you call any variable in my environment. I'm going to remove that. So rm list ls will remove all these files. Right. Now the next thing is I'm going to include these two libraries. Some of you might have them with you already, but for those who, I think most of you might not have them in your computers. So you need to install text mining library, that is TM, and then word cloud library. So you can do this by typing install.packages, and inside the brackets you can within parentheses you can write TM or you can write word cloud, and it will install these things in your computer, and then you can call them. You can either type library or require. Both will do the same thing. So require will give you the same package, or library will call the package. So library TM and library word cloud, these two libraries are the ones that we will be using for this particular work. Right. Now I have shown you the CSV file, right? So I have shown you how the data looks like. So it looks like this. It has these empty spaces and many numbers, all these characters, everything is there. And it's very unorganized. I just scraped it from the web. So, and also it's very difficult to follow, right? So I'm going to open that one. So text read.csv will read that particular CSV. I have given header false because I don't have any headers here. It's just a list of strings. So I'm going to run this one, and I will have this file. You can see 2043 observations, and if you click on this one, you can see all these things which you could see in the Excel, and you can load them up. So everything is here, 2043 observations. And you can see here when I imported that CSV file, it has been imported as a V1. So take a look at this header file. So it's V1. If I didn't say header equals false, the first row will be taken as the header. So I'll have this the Sri Lankan change room, blah, 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 as my name of my column. So I set header false. So it has automatically assigned V1 as my header, as my column name. Okay. Right. Now, the next step. Now, I hope by this time you understood what I've done, and just take a note of what I've done. And, if you are drawing, you can draw that what you have done, like taking this library, taking this just square brackets or whatever. The thing that you feel fine, you can draw that. Okay. Right. Now I'm almost here. Now text corpus is the variable. I'm going to assign it with corpus. Corpus comes, if you type corpus, I haven't imported them. So that's why I'm going to import the libraries. Right. So if I type corpus, you should be able to see that it is inside the TM package. It's inside the natural language processing toolbox. It's in the text mining package. So if you type corpus, now what I've done here, creating the corpus of the vector source text v1. So text v1 is actually the column data, all the data in that data frame. I'm going to create it as a vector source. I'm aligning all those text files as a single vector, and I'm going to create the corpus. Corpus is the amount, the things in that string file. So it's like it's more like a bag containing words. You can understand it like that. It's a big bag, and it contains all sorts of words in this file, in this vector source. So data frame to vector source, and then I'm just extracting the words from that thing. And now I have a text corpus. Right, as you can see, it's a list of these observations. Now you can see that it has been converted to an entire list. Right. So now this text corpus is a list containing all these observations, right? Now I am going to take this one and I'm going to convert all the capital letters to lower letters. Like by doing that, I'm converting any name. Say Angelo Matthews is A and M has to be there in that name. A and M should be capital letters, right? And I have different names, right? Maybe some other names as well. So all these things will be converted to lowercase, because that's how you do the text mining. You convert every abnormalities to formal sense, so that you can take that as a whole. So I'm going to convert those letters to lower. So I have now, don't worry about this warning message, but I have now converted this into lower text. So everything is in the lower. So you don't see anything changed here because I have used the same, and I have assigned that back to the same variable. So if you remember, we can actually align those entire string using that little mark here. I will come to that in when we do the Sherlock Holmes text mining part. So here I have just repeated the same thing. So tm map is the command where we map everything to the lowercase. Right. Then next thing is I'm going to remove the punctuations, so that any punctuation like full stop or a dot or inside quotation mark or anything, which is UTF characters. Okay, so we are working on the Unicode text characters. So everything that is related to Unicode punctuations will be removed from the text here. Text corpus, I'm removing the punctuations. And now the text corpus will contain things without punctuation. So everything is here, but no new variables have been declared. But as you can see now, the text corpus is a list of things without any case and also without punctuations, right? And for the there's a thing that I need to tell you. This head stop words English is a set of stop words in English. Like because we are working on English here, we have different stop words: I, me, my, myself, we, our. There may be so many stop words like this that does not really give a context to the meaning unless there is an association or something. We are not mining the associative rules. We're just mining information out of this one. So we don't need these I, me, my, myself, these kind of stop words. So what I'm going to do here, I'm going to remove any stop words containing in this corpus. So I'm going to remove that, remove words, stop words, English. So when I run this one, you can see that something has changed. If there is any thing related to I, me, you will see this one when you do some other text mining where you have so many my, I, myself sort of things. The number of words will be drastically reduced because we are removing the stop words. For the time being, I'm not executing this one, this 19th line, because I have something to talk about this at the end. So I'm going to strip white spaces here. White spaces means if you have anything, that has a space, like that is a character also, right? So that occupies the space in the string. I'm going to strip out those white spaces as well in the text corpus. So I'm going to run that. And now what do we have? If those who are taking notes, we have imported the data. We have taken that to a vector space and then turned into a corpus and turned the capital letters into lowercase and then remove the punctuations and remove the stop words. I didn't execute this 19th line. I'll come to that later. And I've removed the strip. I have stripped down the white spaces, right? Now, this is a text corpus and it contains kind of the cream of what we want to analyze. It's like taking a chocolate ice cream, say you took a Wonder Bar. What is it? Wonder Bar, I think now it's yeah, Cornetto. You take a Cornetto and you remove the casing and even you took out the ice cream part and now you are left with the kind of the cone, right? So now it's like that. If you like the cone, you can eat the cone. Or if you like the chocolate part at the right at the corner, you can take that out and eat. So I'm just kind of taking that out now. So you are left with just the words. Now, term document matrix, or you can flip it, document term matrix. This is one term, or you can actually use document term matrix. If you do that, you get a flipped matrix. You have to transform that matrix, but here I'm using term document matrix. You convert the text corpus into a matrix. So what you do here is that it's like the number frequency of a word is taken into a matrix. It's like a table. So when I run this one, DTM, you can see there's a new creation called DTM, list of something. So if you go here, you can see what it means. So here you can see terms, character. You see so many characters and the number of characters are also here. So how many times each word has been mentioned. So I'm going to convert this term document matrix into an actual matrix. So when I run this one, it creates a large matrix. If you go here, go in, now it's no more. Let's go to that, click again. You can see what I meant. So now the information about the repetition and the frequency of the words have been transferred to a large matrix. So this matrix contain it's like a marker. It's like how many times this thing has happened. Those who have played cricket, you know that there is a when we score, you just put like a slash, like, so if it is a 4, you just put 4 dots or just 4 slashes, so that anybody who's marking you, they know. And also for a over, you have 6 dots, and like an empty ball, or like no mark or no score is a dot, and then if it's a 4, you just put a 4, like kind of. This indicates how many times that particular word has appeared in different contexts or different strings in this particular matrix. So now it's a matrix. Now I'm going to get the number of occurrences by getting the row sums of this DTM. So I'm going to run it. So now I have a value matrix, which is the sum. So basically, I've converted the frequencies to sum of frequencies, which means I know if there is a word, how many times that particular word has appeared in this list of strings. And I'm going to sort it in the decreasing order, so that I have the highest frequency at the top and the lowest frequency at the bottom. Okay. So when I run it, it automatically applies that sorting part. Now this is the fun part. So I'm going to show you something. This set seed 1, 2, 3, 4 is actually when you set this seed, you will always get the same figure. That's why we set it, so that when I do it and when you do it, the figure would be the same. So when I run it, I'm going to run this whole thing. Set seed 1, 2, 3, 4, word cloud, head, names, number of occurrences. So number of occurrences is the sorted matrix containing the names of the word. That names means the words, and number of occurrences is basically the number. So I'm going to run this command. When I run it, you can see this particular figure. You can see the large figure, like the large text indicates the significance. So if you watch the match, or if you are aware of the match, you know what happened. So Angelo Matthews scored 199, and then these are bowlers from Bangladesh, and then Shakib, Naeem. And then we have Visha Fernando, who batted with Angelo, I think, at the end for some time. And I think there should be Chandimal, but I think I think it has played more than that. So we have some other things that also contain within this one. For example, like we have this full leg end runs, kind of this runs is kind of nothing important in terms of the context, so we might need to remove it, right? So if you want to remove it, you can run this. So you can create a matrix, or sorry, a vector file here using those words that really that don't give any meaning. So if you want to extract information or understand the data, if certain words are kind of not really the things that you want, you can actually remove them. So if I want to remove runs from this, I can say runs, and then run this command, and I can follow the same thing all the way up to here, and let's see whether it's going to change anything. As you can see, now runs have been removed, but run is there. So you can actually add the run part here as well, and then execute it. And then from here onwards, you can go all the way up to here and then run it. And you can see some meaningful things will be there. So Chandimal is here, right? You can see that Chandimal has come into the picture with when we remove those unnecessary words, kind of we can get a better picture of what's happened. So this is the word cloud of that very lengthy list of strings, right? So this is just the black and white of it. So you can actually do the same thing with colors. When I do it, you can see a very nice picture of what's happened. So you have, the colors indicate how close they are in terms of the frequency. For example, if you take Matthews and Angelo, they are kind of there, but Fernando, Shakib, they appeared to be very close to each other. And then Taijul outside, then I think Chandimal is there, and also Islam, Shariful Islam around, and then tossed about. So you can see that there was some bowling from the spinners, bowling tossed up stump that is actually around the stumps or something. They have also defend a lot of defenses, and full some idea about what's happened. And also you can do something to change this one by altering and filtering these text. I leave it up to you. So that's about actually using the text processing, pre-processing, to get a better idea of what's happened in a given context, right? So that's about also data wrangling and identifying what's happened in that. So those who are drawing the thing or writing down the notes, you can get an idea of what's happened in that one and keep that note with you. And for the other one, now this is about the cricket commentary. Let's move to the other one, that is about the Sherlock Holmes part. Now, the first few lines are the same lines, so I'm not going to do that. I don't need to remove the list as well, so I'll keep it. And the next one, now for this one, I am going to use the package management tool in R. We call it Pacman. So it's easy to remember. Pacman contains the package management ability. So when we open up Pacman, you don't need to say, like in the previous case, I imported several libraries, library TM, library word cloud. I had to write them separately, right? But in this case here, I don't need to do that because I'm importing library Pacman, so package management tool, and then I just need to type Pacman and then colon, 2 colons, and then P load indicates package load, Pacman of course, and then TM, text mining tool, Snowball C, and DPLYR. Those are the packages that I'm going to use in this particular text mining task. Actually, you can, if you haven't installed this one, you can follow the same thing. Install.packages. Pacman will install you this package management library. So I'm going to do this now. Let me run this one. Okay, now let me first of all remove this one, otherwise they will interfere with me in the work. So I'm going to remove the other packages and I'm going to run this one here. Right, once I do that, I'm going to now read the Holmes Baskerville. This actually the text is actually about Holmes Hound of the Baskerville. So if I go to the Holmes text mining, I think it's this one. Yeah, this is actually the R file. Where's my text file? 285. So if you go to this, you can find the Sherlock Holmes story starting from where the Arthur Conan Doyle and this Sherlock Holmes chapter 1 and everything is there. It's actually a text file containing the full book. So what happened in the Baskerville, and take a note that this particular part is not Unicode encoded. So we will find some problems related to this one. So other than that, everything is like okay. So every detail about the book is here. Actually, this is the book. So it's a text form of the book. Right now, I'm going to, where's my R? So I'm going to use this one and I'm going to import this text file into our studio. So Holmes B, Baskerville Holmes, just to indicate that. Now I'm importing a text file, therefore I'm writing a read lines command, read lines.txt. So it will import Holmes. So you have 7,729 elements. So it's a large character, as you can see. Right. I'm going to do the same thing. I'm creating the corpus from the vector source, creating a vector source from the string set, and then I'm going to create the corpus from that. Right now I have a very large set of characters as a corpus. Now if you remember this particular thing, I did this one last time. I'm combining the list of commands that I did previously. Now here I repeated this tm map. I put this text corpus back to here, then this text corpus back to here, etc. I have to type it all the way up, assigning the same variable again and again. Instead of that, what I have done is I have used this shorten command so that the corpus Holmes will be corpus Holmes sent to each of these commands. So tm map, first of all, remove numbers. I don't need numbers. I'm going to remove them. And then remove punctuations, strip white spaces, and then content transformer to lower. So I'm transforming now I've used content transformer as here. I just put tm map text corpus to lower, but here I'm transferring using the content transformer to lower. So I'm going to run this one. Just placing it here and running it would do all these things. So because it's a single code, so everything will be in the same line. So I have corpus Holmes, large simple corpus with all these elements here. And next thing I'm going to do is I'm going to remove the stop words in the English, myself, I, all those things that I have shown you earlier. I'm going to remove them by running, and don't worry about this warning message. So it will be done. Now I'm going to create the term document matrix with the remove sparse terms. Now, what do you mean by remove sparse terms? Sparse terms are things like, for example, when you think about something now in the case of Hound of the Baskerville also, maybe the dog will appear only very few times. So the frequency will be less. When we do the analysis, it's actually something about the philosophy of the analysis. We consider about the higher frequency, not about the anomaly. So we remove the less frequent words. So we call them sparse terms. We remove those terms because we assume that the higher frequency words have more meaning or more context in this analysis. Therefore, we remove the sparse terms so that to remove the space in our analysis to take the most vital information from the text. But if you are really looking into the text mining of it, like getting that very important message. For example, if you are working in the defense sector and there is a certain name that you have to mine out from the text, then this it will be the past tense. Okay, so that particular thing would be required. So in such cases, you have to actually adjust this code a bit, or think about it in a different way. Now, but in this case, I'm removing the sparse terms. So sparse terms is like the percentage of the frequency. It's like the relative frequency. So I'm going to remove anything that has like five, say, length of the corpus forms. If you say you have 200 words, so I'm going to kind of remove the words that only appeared 5 times in the text, kind of. So like 20% of it will be removed, and I'm only focusing about the next. So you can actually have a decimal value here as well, but that value needs to be between 0 and 0.99. So you cannot be 1. If it is 1, that means there's no need of it. So 0 to 1 is the scale. So if you put a decimal value, you define the frequency that you have to consider removing, right? So I'm creating that DTM matrix here. So term document matrix, right? So I'm going to get that one similar to the previous case. I'm creating the matrix and I'm going to sort them in the decreasing order. Likewise, I did in the previous case. Now there's a matrix called words. So if I open this up, it might not appear here, but I can actually create a data frame. So data frame from the words, names inside it. I create 2 columns. First, now this is a data frame. In the data frame, the first column is word. Word comes from the names in words, and absolute frequency is the number, the number of the words appearance. Relative frequency is the total the number of words divided by the total number of words. So when I run this data frame command, you should get a data frame called df. With this data frame, you can see the name. So word is here, absolute frequency is here, and the relative frequency is here. So as you can see, sir has appeared 321 times in the text. And as I told you, these quotation marks, they are not UTF codes. So they have appeared several times. You can actually remove them, but I'll show you something else as well, how to tackle them. And then you have said. Said is not needed as well. You can maybe remove will from it. And more is a very important thing. If you have read Hound of the Baskerville, you know that more is an important thing. Henry and Baskerville is here. So it's very, very interesting. So to look at this, right? Watson, Mortimer. Mortimer is also a very important character of this story. So it's a very interesting. Ice. Yeah, ice is also an important thing because if you remember, it is actually, for those who haven't read the book, I'm sorry, but for those who have read the book, you know that the eyes of the dog is a very important thing in this this story. So hound is there, right? So so all these important points have been captured. Now you have the data frame containing the word and the word absolute frequencies as well as the relative frequencies. So I'm going to use the same seed, and then I'm going to do the same command to create the word cloud. But here I have done an important data wrangling task. I have sliced it from data frame from 6 to 10, because I know that those first few things are not really important to me. So I'm going to slice it for slice it to a given frequencies, set of frequencies from the column, from the rows, and I'm going to take the frequencies of those words as absolute frequencies, right? So I'm going to slicing it. I'm doing the slicing from the data frame, right? When I run this, you'll see a very nice figure. So let me show you the figure. So if this is from the previous one. So if I run it, you can see man, homes, more will be there, because I have used only a few slices here. So I can actually go up to 20 per se, for example, first 20 part. And if I run this one, you can see more things have appeared here. So Henry, Baskerville, Holmes, project, more, all these things have appeared now in the task itself, right? So this is the word cloud of things that have happened. Now I can actually extend this work a bit further, and I can develop a bar plot of this one. So I'm going to remove the row names of the data frame, and I'm going to do this ggplot2 command to create a bar plot of the set of words. So I'm going to run that. So when I run it, you can see I have flipped it. So it's easy to see. You can see the number of words appearing here as a bar chart. So I can actually go up to change that, and maybe 6 to 20 as I did, and then run this command. You'll see all the things, not like the word cloud, but as the frequent histogram of things, how it has happened, right? For if for example, this one, now those things are not needed, you can go up to removing the terms, remove the words, and remove Will's one here as I done. So you can actually run this all the way up to here, and then actually see that they have changed, and you can take up the most important terms, right? So then about the filtering, this is slicing. You can go and do the filtering as well, where you say that you are interested in the in the frequencies where the words are from 400 to 1000. You can apply the filter here and run this command so that you screen out the things out of it. I think there is no word here, so maybe I'll go up to less than, greater than 100 maybe. If you run it, yeah, some words will be there. And then if I go and do some digging inside, also you can check what are the words. They are almost, they are less than 200 maybe. Yeah, some you can actually dig into the file and see what are the words that appear most of the time. So Holmes and Henry, Baskerville will be there, and also you can remove these can, may sort of things from the scope, from the corpus, and see the final outcome as well. So actually this is very interesting, and most of your seniors are doing things related to text analytics and natural language processing related R&D work. So in the future, if you are interested in, you can actually get into those kind of work, and it's very interesting, and it's very fun to look at these things as well, right? So this is the activity that I was mentioning in the beginning. So you have followed these things with me up to now. So I'm going to upload the codes as well to the Moodle. You can actually follow them and keep them with you. If you want to do anything in the future with them, you can go ahead and do them. I don't mind. So you can use my codes, no problem. You can have fun with them. Now it's the time that you have. I'll give you 10 minutes to upload whatever that you have learned from this activity. You can go to the Moodle, take this first link because you are in the lecture, go to this text mining and wrangling in R, upload. As I told you, I'll repeat the instructions if you want. The instruction is that you have to take a piece of paper and write or draw what you understood from these codes and how I did it, and then any note related to the learning process, and what did you do and what sort of things you learned from here. You can include all these things in the single paper, and then take a scan or a PDF of it, scan it, and then upload it to here. I'll separately give look at it, and then I'll do the necessary things afterwards. For those who are in the lecture, please follow this link. For those who will be watching this video from the link or from the recording, you need to follow the second link. So can you please go here and then do the needful? I will give you 10 minutes. In fact, I can stop the lecture here. You can take your 10 minutes and upload it here. Now it's 2. The opening is there until 3 p.m. So I don't want to keep you here next to the computer. You can actually do it, but the link will be only available till 3 p.m. because it was prepared for those who will be coming to the lecture, doing this in the lecture. And for others, the link will be opening from 3 p.m. onwards, right? So don't worry about the other submissions. I will update the deadlines for these submissions so that you have at least 1 week ahead. Maybe I'll give you time till the end of this month. So I'll all the way shift it up to 30th Monday. Okay. So I'll open it up to that month, 30th Monday, but don't ask me to extend it further. I need you to finish all these remaining assignment. For those who cannot upload it here, please mention 3110 and send it to the relevant name on the Moodle about the assignment and send the attached answer script to me. And then I will separately allow you a different time to upload it. But for those, because for some cases I cannot really say upload it. Okay, here's what I'm going to do. I'll give all these upload limits. I'll do it up to now. For example, if I go to class 6 project, 49 have uploaded. So I don't need to extend that one because 49 of you have uploaded it. Now, if I go to this one, I think assignment report, only 3 have uploaded it. So I'll extend this one, right? This one till 30th of this month and also remaining part. So the assignment, that is this one, this one, and these things, these 2 will be extended up to 30th of May. All right. So if you don't have any questions, you can leave and actually upload the thing to here. And for those who have any questions, you can ask me.